C3I, Command, Control, Communications and Intelligence Requirements. This is a 1999 presentation. So the ideas ought to be old, but apparently they aren't. There are some difficult issues here in establishing sound requirements for C3I. It is in fact a profoundly intractable problem. The US industry's approach exhibits a messianic obsession with technology since the 1970s. Understanding how humans make decisions is scarcely considered a respectable subject. The requirements difficulty is relative to the degree of uncertainty. For the UK air defence ground environment, there's a prescribed threat spectrum and prescribed tactics. So the system can be automated, and really there's a simple decision to make: react to enemy or don't react. For strategic C3I, there are vast amounts of partial or conflicting information and an unpredictable enemy. So it's a completely different situation. C3I information systems feeding teams of intelligence, operation and logistics personnel. Potential information overload. And when you've finished, you've made an extremely attractive target for the enemy to attack. International peace operations become an issue. The military task there is uncertain. Is it peacemaking, peacekeeping, peace building? All three? Any two out of three? Alien cultures there with no obvious enemy. There's a very high degree of situation sensitivity. And when it's boiled down to it, what does effectiveness mean in the context of peacemaking, peacekeeping and peace building? Part of the obsession is with measurement. Measure the performance of each part of the C3I, weigh each measure of performance and sum the weighted scores. This is nonsense. Does it give process useful measurement of overall C3I? No, it doesn't. The process is reductionist, ignores the interactions between the parts, ignores fundamental systems theory. Yet this is the typical procedure. Typical C3I system is highly interactive, tightly coupled human activity systems, supported by essentially simple information handling and presentation systems. It's nonlinear dynamics. C3I systems must obey the classic system principles. The first principle: the properties, capabilities and behaviours of a system derive both from its parts and from the interaction between those parts. And the corollary of the first principle: altering the properties or behaviours of any of the parts or any of their interactions affects other parts, the whole system, and interacting systems. So we have an information collection part, a situation awareness part, a strategy development part, a resources management part, and control and coordination. Let's put some flesh on the bones. Now, if you'd like to follow the whole of that through, from, for example, intelligence, bottom left, helps to establish situation assessment. With opportunities and threat assessment, generates options in strategy development. Depending on the constraint, a course of action may be derived. Orders and instructions may be formed for control and coordination, and so on. It's not that complicated when you look at it at this abstract level. But it does look as though you can examine it under three headings: information, making a decision on the basis of that information, and then taking action. And that's continually happening and dynamic, because every action changes the information you gather. So measuring parts of C3I in isolation is not helpful. Instead, measure the emergent properties, capabilities and behaviours of the whole C3I and vary the parts in turn so as to optimise the effectiveness of the whole in operation for archetypal scenarios. That would be awkward to do in practice in real time, so one could sensibly resort to simulation. In other words, a systems engineering virtual reality system. SCVR, Systems Engineering Virtual Reality. And what to measure? Cost exchange ratios, casualty exchange ratios, territorial gain or loss, disorder reduction for peacekeeping. Actually, it's not that obvious since any measure is politically charged, for example, the US body bag syndrome. And a high cost at one level may save much more at another level. It's difficult to know what to do. Alternatively, where the situation is non-linear, dynamic, unpredictable, the alternative is Kaizen, progressive improvement. De facto development of C3I in former Yugoslavia was continuous improvement. Measurement was largely irrelevant. The UK defence was so tightly locked into a measurement paradigm that Kaizen equated to muddling through, not being properly prepared, etc. Kaizen may only be feasible approach, however, as an environment is in continual flux. So actual measures don't really make a lot of sense. Let's look at the basic command and control decision circle. We start at the top with assess situation, then identify threats and opportunities, generate feasible options, select the preferred option, initiate the action, and monitor progress. As a result of the initiated action, the situation will change. So as you assess the situation, it will change, and so you go around the circle again and again. And once this starts, it just continues to go round and round. We may elaborate on each of these to get a situation which looks rather like this. We can see who the people are. Commander, operations, intelligence are doing situation attending. Identify threats and opportunities is the role of intelligence. Then ops is intelligence and ops working together. Constraints come from logistics. Selecting the option is the commander's choice. Initiate the action is operations, intelligence and logistics together. Monitor progress is ops and intelligence. And we come back to the top again. The decision circle. You can build on the decision circle. You can see the circle in the centre as before, and then each one of them is elaborated. So it's that situation at the top we see is done by gathering own, friendly, neutral and hostile data, set against the environment and in context, examine the information and changes, and assess the situation, and round we go. Let's look at another one. Review constraints, down at 5 o'clock. Review constraints, examine current commitments, review priorities, identify releasable assets, match assets to feasible options. Looks sensible. Select preferred option, initiate, and all the way around the circle. So there's quite a lot to each of these, but essentially this works like a set of gear wheels, with the outer gear wheels rotating to turn the inner wheel. It all fits together. C3I requirements, information on enemy resources and constraints, expert personnel able to make timely and effective decisions, technology that's adaptable to dynamically changing situations, an infrastructure and architecture connecting all four, some common operating environment with multiple OS with interportability, the whole to be evolvable in near real time. Not much to that. Let's look at architectures. That's what the architecture in the former Yugoslavia looked like, with lots of individual nations involved, Lots of different parties involved. There were refugees in the UN, different nations were involved, civilian aid agencies, casualties, Red Cross, national evacuation, separate logistics departments. There was also the war in local population. That was the whole thing, and that evolved over time to be a bit of a mess. Oh, if you look at the C3I side, you can see that there are congruent hierarchies, as I call them, in there. We can see a number of command and control teams, and there's a higher level one at the top, and then 3 lower formations at the bottom. You can see inside each command and control team we have operation, intelligence, plans, logistics and engineering. And each communicates via the linkages shown, interlinks between teams, with the other teams. As shown at the moment, you can see that operations is in red, and the red network is connecting all of the operations people. So the communications between operations and operations is external, but the communications within the command and control team between, say, operations and intelligence and plans and so forth, is all inside each C2 team. It's like a series of overlaid networks. And we have a designed organisation at the left. Well, a designed organisation is all very well, but what happens in practice is it ends up looking like this, with de facto teams, roles in other command and control systems, fragmented internal structure. So what happens in reality looks nothing like the designed organisation, although it may try and work in much the same way. Let's look at this in a layered form. There's an operational technology interface. At the role we can see, at the top we can see the humans, taking in information, making decisions and initiating actions. That's a role relationship structure. Now each of the players there has something to do with information systems, and so there is a C2 technology and information system layer underneath and supporting the role relationship structure. And you can see there's a technology layer at the bottom with different networks. And what we've got here is the top one laid down on top of the middle one, and that's what you see at the bottom. And from that we can determine what the C2 architecture generic reference model looks like. Information in blue again, decisions in red and actions in green. And you can see how they're all joined together. And while you can look at each bit and find it sensible, the whole lot looks a bit of a mess. But it's not that bad really. It's no worse than commercial information systems architectures. Here set up with LANs, wide area networks, servers, the whole bit. I've chosen a little bit of lightheartedness here. The psychology of operation rooms layouts. And this is how it works in Star Trek, the original series. We have the captain in his swivel chair, and he can look down on the operators below, or he can turn his chair around and look towards science and communications who are at the back. And you can see the logic of all of these things. Science and communications are reactive, outward looking. The operators are controlled, but they're outward looking, weapons, navigation, attitude and speed. There's a large screen display which is outward looking, which everyone can see. Engineering is sidelined, where Scotty stands, and the whole works together in a sensible fashion. In fact, it's a perfectly rational setup. on Star Trek. 2 ways to create effective command and control systems. One is a human-centered view of command and control organization. No job so mundane that it lacks a wrinkle. Experienced command systems operators have already learnt many wrinkles as individuals, but also as teams. They know so much, they forget how much they know. Requirements capture is therefore virtually impossible by present methods, with amateurs quizzing experts, building fast prototypes. A sensible conclusion then is that we should use expert command system operators to capture their own requirements. And another observation, the best C3I systems evolve. And so we can take an accelerated evolution approach, AEA. Step 1, create a human command and system team. Step 2, give the team time to build a repertoire of individual and group skills, interpersonal relationships and group effectiveness. And then step 3, stress the team. Simulated command, cooperation with other force elements, real drudgery and challenging situations. Continue until the manual team is highly proficient. Step 4, have the team identify its own sub-teams, bottlenecks, areas for improvement. Step 5, provide the team with its proposed support. Step 6, reduce the manpower. Step 7, resist the temptation to integrate the technological support features. And 2 ways to create effective C3I systems. The second way is use operational synthetic environments. This will build, and at the top we can see generic facilities, adaptable staff, context-sensitive methods, all trying to get a handle on the situation dynamics as the environment changes. We can see the introduction of rapid modelling tools and the ability to represent the situation. Dynamic social models, simulations, rapid prototypes, synthetic environments. These take in local knowledge and local intelligence to improve the representation. And we have trialed concepts and approaches, collection plans and adaptation. And finally we can get out of that synthesized methods and strategies, storylines, representations and what-ifs. That should give us assured performance, controlled actions, and in the face of hostile counteractions. So we should be able to control system dynamics and control hostile counteractions. Synthetic environments, as the bullets say, enable rapid situation prototyping. Prototypes test context-sensitive methods, use local knowledge to validate prototypes and resulting strategies and methods. Synthetic environments reveal intelligent shortfalls and collection plans. So there's a reduced risk, context-sensitive strategies and plans, particularly relevant to multi-ethnic peacekeeping roles. Conclusions. Current obsession with prescribing C3I requirements. It's very difficult to identify any successful prescriptive C3I procurements. Prescribed processes, procedures, doctrine, data, technology, they're inappropriate to unpredictable conflict. The solution is fairly obvious: to create context-free generic C3I, minimize the technology and its integration, maximize domain experts, evolve in simulated then real environments, replace prescription and measurements with Kaizen, continuous improvement. So C3 requirement is for process, not for product. And there we are.